think we're live. Hello. Okay, so we're going to start shortly. Just waiting for people to sign in, and obviously we've got the comments up as well. Hello. Excellent. Okay, looks like we're starting. Right, we've got loads planned. We've got pure, we've got stats, we've got mechanics. So it'll all be coming up soon. We'll just give it a minute to make sure it's all working properly, and then we'll get started. Cool, excellent. Okay. Right, welcome everyone if you're just joining. I'm about to share the screen shortly so we can get straight on with this and have a look at some maths revision for A-level mocks. So I'm going to share the screen shortly. Hopefully we can all hear. This is all good. Do let me know if there's any issues with the sound or anything. Okay. Okay, so should be approximately an hour. I'm going to work through a load of maths questions, and I'll also tell you a bit about Snap Revise as well. So I'm going to start sharing the screen now, and we'll get straight onto the maths. And as I said, any questions, keep them coming in the chat box, and I'll do my best to answer as many as I can. Okay, right, so let's share the correct screen here. And do let me know if we can see. Here we go. About to get started. Okay, right. Hopefully, let me just sort myself out here with a pen. Brilliant. Okay, right. So welcome to the maths web class. I'm just going to get the pen sorted on my laptop so that we can work through this. Here we go. So a bit of revision for A-level maths. And as I said, it will cover pure, it will cover mechanics, it will cover statistics. So hopefully we've picked some good questions to run through and it's all clear for you all. So here we go. It's quite generic, so should work for most exam boards. But as I said, any questions, do put them in the chat and I'll do my best. Right, so I'm Max. I'm head of maths at Snap Revise, and I did my bachelor's degree in maths at King's College London. And I've taught maths for the last 4 years at A-level, so hopefully know enough to kind of help you out today. And I work for Snap Revise as well, doing webinars, web classes each week. So hopefully that's enough about me. We'll carry on. So just the aim of this web class today, obviously it's a key time for mocks. We're going to look at question analysis, mark scheme language, a bit about exam technique, and just look at kind of the range of questions really. And it's a really good opportunity to look at how we should maybe work through and approach these questions. So let's have a little look. Hopefully we can see the slides all okay. Right, let's move on. So just a kind of quick thing about today's YouTube live stream as well. There will be a free account for one person given away. So this is really kind of key that if you are enjoying this, you like this and you're interested in that free account, if you take a picture of this web class and share it on your Insta story and make sure you tag at Snap Revise, as I said, there'll be a free account given away for one. So that's kind of a little perk of today's web class. So just bear that in mind. It might be something you want to get on and do. That'd be great. Cool. Right. And there'll also be a one-time seriously big discount, a code at the end. So stay tuned because that will expire and you might want to enter that for a discount on Snap Revise as well. Brilliant. Okay. So let's have a little look. Right, we'll move on. So to get started, we'll look at some pure maths. So a bit of a recap of the calculus you will have done. And I'm just going to make sure I'm all set up and ready to go here with this. So here we go. A bit of differentiation and integration. What we've got is we've got the derivative. So the first thing I would actually do with this is rewrite this question in a form that I'm happy with. 4x to the half. Okay. And hopefully that's all clear, you can see that. And the first thing we're going to do, so we're going to differentiate this. We're going to find dy by dx. And remember, for a really straightforward polynomial, or basically anything with powers of x, you times by the power and then subtract 1 from the power. So here we go. You're going to get 3 multiplied by the 2, so 6x to the 1. You can just leave it as 6x. And then add, and then you're going to multiply by the half. So you're going to get 4 over 2x and minus 1 from the power to the minus a half, which obviously we can just write as 6x plus 2x to the minus a half. Okay, and hopefully we're good with that. So this should be something hopefully we've seen before, just kind of a straightforward derivative. If you're then asked to do the second derivative, all you do is essentially differentiate it again. So this might be quite straightforward for some of you, just a little kind of quick recap. Do look out for it though, particularly the negative and fractional powers. They do typically trip people up sometimes. So here we go. Okay, so differentiating again, the previous part. So the power is 1 multiplied by 1, and obviously 6x will just become a constant. It will just become 6. And then multiplying by minus a half, we're going to get minus 2. And then obviously times it by half, so minus x to the minus 3 over 2. Okay. And again, that's fine, or equivalent. Any equivalent form would be fine. So that's part A and B. That's the differentiation done. Part C, we're going to look at integrating. So integrating y, integrating 3x squared with respect to x. That's good. And we should recognize integration as the reverse process of differentiation. So for this, you you add 1 to the power and divide by the new power. So for this one, we're going to add 1 to the 2 and then divide by that. So we're going to get 3x cubed over 3 and then add 1 to the power and divide by that. So we're going to get 4x to the 3 over 2 divided by 3 over 2, and then we need to remember plus c. This is perhaps the complicated bit, dividing by a fraction. Remember, it's the same as flipping and multiplying. So this will tidy up as x cubed plus 8 over 3, x to the 3 over 2, and don't forget your plus c. So this is your indefinite integration. It's not bounded, so this is kind of important. Make sure we don't forget that. Excellent. Right, so we're going to move on. As I said, any questions, do mention in the chat as you go. That's fine. Right, we'll move on. So here we go. A curve C has the equation y equals x squared multiplied by x minus 6 plus 4 over x. And we're asked to show that the length of PQ is root 170, and they've given us the x coordinates. Okay, so what we're going to do here, and I'm just going to check that this is all clear for everyone still. Let's have a little look. Brilliant. Okay, yes, we are going to move on. And yeah, first question. So feel free to do this alongside. This is absolutely, as some people have mentioned in the chat, using Pythagoras. Well done. So what we're going to do is firstly look at what's happening when x equals 1. So if we sub x equals 1 in, we get y equals y equals 1 times minus 5, add 4, which is minus 1. So one of your points there straight away is 1 minus 1. And then you do the exact same thing for when x is 2. And it's brilliant that this seems quite clear to people. This is a recap that basically once you've found your coordinates, we're just applying Pythagoras to find the lengths. So if that's clear to you, that's excellent, because it's a really nice first part of this question. And the other good thing is to show that, so you kind of know if you've got it right or not. Okay. So here we go. So we're subbing in x equals 2. And we want y equals 2 squared, 2 minus 6 plus 4 over 2. So that's going to be 4 times minus 4 plus the 1. Excellent. So we're going to get y equals 2. And let me just double check my maths there. I think it was minus 13. We getting that? Happy with this? Let's just check we're all good with that. Sorry, oh, it's gone back. Minus 14, let's double check. 4 minus, yeah, cool, plus 2, so minus 14. So this point is 2 minus 14. Lovely. So now that we've got P and Q, that's brilliant. 1 minus 1, 2 minus 14. We're going to use Pythagoras on that. And obviously, if you do make a numerical error, because it's a show that, we know if we've gone wrong or not. Because obviously it won't come out correctly. So when we use Pythagoras here, we're going to look at the change in x, the difference in x squared plus the difference in y squared. So the difference in x, we know is going to be the difference between 2 and 1. And the difference in y, we're going to look at minus 14 and then minus 1, which is essentially plus. So we're going to get the square root of 1 plus 13 squared, 169, so square root of 170, which is what we wanted. That's great. Okay, so that finds the distance. And guys, remember that that's the reason for this is because essentially if we've got our x distance and our y distance, the change in x, the change in y in terms of the difference squared forms a right angle triangle. So that's how we can use it to find a length between 2 points. Brilliant. Okay, so we will move on. Hopefully that's good. Okay, so next part of the question, 5 marks here. Show that the tangents to C at P and Q are parallel. Now the thing that should be sort of jumping out with this question is parallel is talking about the gradient. So it's hinting to do differentiation. So if we can differentiate and find the gradient at those points, if it's the same, then they're parallel and we've done it, okay? So exactly. So let's have a little look. So we're going to differentiate this. The first thing I would do again is rewrite that out kind of in a nicer way. So if I expand the first bracket here, I'm going to get x cubed minus 6x squared plus 4x to the minus 1. If I differentiate that, 3x squared minus 12x minus 4x to the minus 2. And as I said, feel free to do this alongside and check we get the same thing. That'd be brilliant. Okay, so here we go. We've got the derivative. We can sub in when x is 1 and when x is 2. So x equals 1 gradient 3 times 1 squared minus 12 times 1 minus 4 times 1 to the minus 2. And that's going to be 3 times 1 minus 12 minus 4. And we're going to get a gradient of minus 13. Okay, so if we now do the exact same thing for x is 2, let's look at what the gradient is. And right, here we go. So we're going to sub 2 in as x. So 2, so it's 3 times 2 squared minus 12 times 2 minus 4, 2 to the minus 2. And again, just checking that. 2 squared is 4 times 3 is 12. 12 minus 12 times 2 is minus 12. Minus 4 times 2 to the minus 2. That will tidy up to minus 1. So again, we get minus 13. Okay, and hopefully that's clear to everyone. This actually answers the question. The fact that I've got both of these as the same value, the same gradient, I've shown that the steepness is the same at both of those points. So I've used the derivative, which is a function for calculating the gradient, and therefore they are parallel. So I've answered the question. So you could maybe summarize this and say they're the same gradient, therefore parallel, but that has essentially done it. This is probably the best method, if I'm honest. It's what the language in the question is hinting that you do, as well as the number of marks. I mean, obviously, as well, if you're given 2 points, you can find a gradient from 2 points, but this is not what this is asking. This is asking for the exact steepness at a point and also at another point, and checking that those tangents are parallel. So this is really a differentiation question. So there we go. So same gradient. And then therefore parallel. Cool. Right, excellent. Hopefully that's clear to everyone, but we will move on. So a bit more on this question now. And this is a very typical style of question here, the way they've asked you to give the answer. So they've said, find an equation for the normal to C at P, giving your answer in the form AX plus BY plus C equals 0, and A, B, and C have to be integers. Okay, so they need to be whole numbers and they need to be in that form. And often we like to put it in the form y equals mx plus c, but we do need to look out for this because this is very common that exams will ask you for it to be written in a certain way. And it would be awful to lose the marks when you've done it all right, essentially, and just given it in the wrong form. Okay, brilliant. So yes, so hopefully on the last question, we're all still clear. If the gradient's the same, that essentially means they're parallel. So hopefully that's clear. But what we'll do is we'll look at this one now, because it's another little scenario that we need to be aware about. So the normal of a curve is kind of the opposite of the tangent. It's not the same gradient, it's perpendicular. So this is going to have the negative reciprocal gradient. So that's what we know straight away that we're dealing with. So since we've already found the gradient in the previous question, gradient of C at point P equals minus 13, then hopefully we recognize that the normal, the perpendicular line to this, will have gradient 1 over 13 because it's the negative reciprocal. So you change the signs and you kind of flip the fraction essentially, do 1 over it. So gradient of normal equals 1/13. Oh, 1/13, there we go. Okay, and that's really key. And what we're starting to notice is this obviously isn't an integer. And if we start subbing this in, then we've already got a fraction. So we are going to need to bear that in mind working towards the answer we're trying to get. So hopefully we know what we can do here. Brilliant. So what we've got is we want to sub this in to the form of a straight line. And we often use y minus y1. So y minus the point we're dealing with. Let's remind ourselves that the point was minus 1. Sorry, what was the point? No, sorry, it was 1 minus. Oh, let's just double check, make sure we got this correct. It was 1 minus 1. There we go. So y minus y1 is equal to m, and then x minus x1. So that's minus 1. There we go. And hopefully people recognize this. This is kind of the general form of a straight line. Some people do use y equals mx plus c, but this is basically subbing in a point and a gradient, we should be able to get the line. So we do know that the gradient of the normal is a 13th, and we do also know that the point we want to fix it going through is 1 minus 1. So if we sub that information in here, y plus 1, okay, and we can kind of expand and tidy this up. The kind of key thing I would do here probably at this stage is looking at where we're going with this, multiply through by 13. and then immediately we don't have any fractions. So we'll end up with 13y plus 13. And then we're almost there, except obviously we want it all equal to 0. So we're going to rearrange this. And we're going to get x minus 13y minus 14 equals 0. Bringing these two parts over to here. And actually, if you rearranged it the other way, so if you had basically all the opposite signs and you brought these two this way, minus x plus 13y plus 14 equals 0 is absolutely fine as well. Either of these would be acceptable. The mark scheme will say or equivalent. So it basically just is essentially because you're moving it to the other side of 0. But they're all integers and they're actually all set equal to 0. So you've given it in the form that they want. Okay. So yeah, just going back over this bit to clarify for some people. I personally, at this stage, I think this is what people are asking about. Oh, sorry about that, the phone's ringing. Let's just cancel that. Oh no, an important call, clearly. What we do need to look out for is that don't multiply through by a fraction, okay? Because I think that's what's confused people, is when they expanded this 1/13 x minus 1, it's the issue is we get fractions and it gets really messy quickly. By multiplying through by 13, there's no issue, everything's integer straight away and it's just a straight case of rearranging. Hopefully that's all right. Brilliant. Right, sorry again about the call, guys. That was very loud and right in the mic, so I apologize for that. Everyone's trying to take part in this maths, clearly. Right, let's move on. So, brilliant. Right, next type of question, really nice one, this one, is a graph transformation, and we've got some different kind of scenarios here going on. Translation in the y direction, some modulus functions as well. So typically you meet this in year 13, particularly these second two here. So let's have a little look. These shouldn't take too long. Nice questions. And they've given you the graph to work from. So a really good one to go through. Just watch out for the fact that it is obviously A-level style question. Don't do what I've just done and not use a ruler. I'm doing this for the purpose of the sketch. Make sure your axes are clear. The actual sketch, though, for the first question will look very similar. Okay, so f of x plus 3, hopefully we're aware that that's a shift in the upwards direction by 3 units. So essentially the shape of this graph will be very similar. And this point here will have moved to 2, 7. Okay, so this question is really a bit of a recap of a GCSE idea. Okay, so the next question, this is where it perhaps gets a bit more involved. The modulus is a modulus of the entire function. So what this means is y can never be negative. So anything that's below the graph, anything that's negative in y, essentially gets reflected up. So they're two kind of different sketches here. They look like they might be similar, but actually this is what confuses people. So what's going to happen here is it's the same sketch, but instead of going negative, it gets reflected up in the y direction. And so this point will stay where it was. But any negative part of the graph gets reflected up. Okay, and we probably should label our axis as well. Okay, brilliant. So yeah, obviously in an A-level exam, it's a sketch that you want to be making sure you kind of get all the marks for and you do it as best as possible. But it is quite a nice question, and so you would like to do it kind of carefully and make sure it kind of looks good as well. So I've probably just made that worse, but hopefully you guys are happy with what I did there. So yeah, let's put that Through? Okay, this last one, it's interesting to see if people know what's going on here with this one. So f of modulus of x is a very different scenario altogether. What it's saying is basically it kind of mirrors the positive part of the x values in the negative part of the graph. So whatever x goes in as, it gets turned to a positive number before it hits the function. So you kind of modulus x before you get an output. What this ends up doing is the function for the positive x values will be exactly the same. And for the negative x values, it will just mirror that. Okay, so here was 2, 4, minus 2, 4. There we go. Looks like a familiar logo. I'm loving it. So hopefully that's kind of clear to everyone. It's just reflecting the positive x part in the negative x values. So when you put minus 2 in as x, it turns it to positive 2 and copies what that would be doing. Brilliant. Okay, so the modulus stuff might be new for a lot of people, but certainly part A should be very much a recap. So quite a nice question if it comes up, but do be careful with the reflections and the difference between the two types of modulus. Brilliant. Right, we'll move on. Right, nice question that starts to involve logarithms as well. So part A, and the thing I'd be hinting at here as well is in the kind of stress of an exam, you'll see part B, and it won't always to everyone be immediately obvious how that links to part A or how you're going to use part A to speed the question up. So we'll go through it carefully. The first thing I would do with any algebraic fraction is factorize. So quite a nice factorizing question. Let's check we can do it. So the bottom part, the denominator, is hopefully quite straightforward. And the top part, we're looking for two numbers that multiply to make 3, but add to make 4. X plus 3 and x plus 1. There we go. And what we'll notice is that's going to hopefully cancel. And if you do struggle factorizing, obviously this one was quite nice, but if you do the easier part first, if you do x squared plus x, factorize that first, it often hints at one of the factors in the numerator, or vice versa. So this tidies up. Brilliant. Okay, so that's part A done. And so what we're going to do now is obviously as well as we go, try to make the link with the next part of the question. If you did also write this as 1 plus 3 over x, that's absolutely fine. And those of you that have been kind of working through and using partial fractions and you've met that in school, you might be kind of inclined to do that quickly. That's absolutely fine. For the next bit of the question though, this form is perfect. This will still work. Okay, so either of these would be fine for the marks there. But we'll carry on. So part B, find the value of x for which log 2 of what was the numerator minus log 2 of what was the denominator equals 4. So from log rules, I know some of you have mentioned this already, we can combine that information. So we can get that as log 2 4x plus 3 over x squared plus x. And hopefully everyone recognizes that the subtraction of logarithms turns into a division problem. Okay. And we also know from part A that this is the same. Okay. And so what we can do here is to undo a log, we basically can do the power 2 raised to the power of 4 equals what's in the logarithm. And I can see that some of you have recognized this already as the skill we're going to use here. So 2 to the 4, which is 16, must be equal to x plus 3 over x. So 16 equals, so 16x which is a nice linear equation, rearranges to 15x equals 3. So therefore, x equals 1/5. Okay, so let's just kind of clarify that. 15x when you rearrange equals 3. Divide by 15, x equals 3/15, which is 1/5. Okay, and hopefully that's fairly clear. That's a good bit of recap. Brilliant. Right, we'll move on. And as I said, we will try and look at a bit of mechanics and statistics as well. I think we can try and hit the major points for pure, which we've largely done already. So this next question now, a bit of a trig one. This is in radians, so hopefully that's something everyone's kind of met before. And it says to 3SF, so do look out for these parts of the question. Okay, let's have a little look then. So this question is saying tan of half x is equal to 3. And what we're going to do is also remember our cast diagrams. So let's have a little look at that. And some people don't really like these, they don't seem to get on too well with cast, but you can think of the graphs as well if that helps. Essentially, for the first part of this, when you plug this into the calculator and you do inverse tan of both sides, you'll get your first value. The thing to look out for, which I'm sure you're all aware, but just double check in an exam, is that you are in radians. So your angle unit on your calculator is radians and not degrees. It's so much easier to fully work through in radians. So the little R at the top of the calculator will show that. If it's the letter D or G, you're in the wrong unit. So make sure you change it to radians. And then we solve this just like any other trig problem, really. Inverse tan of both sides. And what you're going to get to start with, so you're going to inverse tan. And if we just do that quickly, shift tan of 3, the first value we get is 1.2, and it will be 249, so rounded to 3SF, 25. Okay. Now, tan is positive here and here, and this is clearly positive 3. So we've kind of been given this value, and it might look a little bit strange because it's in radians. So that's obviously in degrees, that would appear a bigger number, but it's still an acute angle. And we know that tan repeats every 180 degrees. So in degrees, we would normally add 180 to that value. But in this, because we're working in radians, the equivalent thing to add on would be pi. Okay, so you will ideally need your calculator here. So if you add pi to that value, so plus, next value we get is 4.39. Okay, and we're searching, if we're looking at 0 to 4 pi for x, something to bear in mind is that for a half x, we only really need to look round as far as 2 pi. So we don't actually need to go beyond that point. Okay, so if that's a half x and I want obviously x, then I double both of those and get x is equal to 2.5 and 8.7. Hopefully that's clear. Okay, and hopefully we're all good with that. Lovely. Okay, so 3SF as well, just check. So 2.50, but that's fine. And there are answers in radians. So actually very much the same as working in degrees. Repeat the bit on radians. Okay, so making sure that in your calculator, the units are not in degrees, they're in radians, because it will change the trig calculations. It will make the values different. If you haven't met radians yet at school, this will appear a little bit confusing, but obviously if you were to do this question in degrees, the method is exactly the same. You would do inverse tan of 3, you'd get an angle and you'd add 180. This is essentially the same process, but we're looking at a different unit for angles. Okay, so let's carry on. So the next question now is the following trig equation, but actually what we're going to see with this one is the first part does link to it again. It is handy having answered that first bit. Okay, so we've got a factorized trig problem, and we're looking in the interval 0 to 2 pi. And what we're going to do here is, so 2 pi radians is the equivalent of 360 degrees. Good. But we're using a different unit for angles. Here, what we're going to look at is, much like when we factorize a quadratic or polynomial or any kind of other problem, if two things multiply to give 0, there's kind of two cases to consider here. Cos theta equals 0, or sine theta minus 3 cos theta equals 0. Okay, so if we solve this one here, when is cos theta equal to 0? Some people find it easiest to picture the cos graph and think what's going on there. It's kind of doing this. So there's a value there, a value there. And so this one is going to be at normally 90 degrees, but because we're working in radians, that would be pi over 2 and 3 pi over 2. So there's two of your solutions there. And then this one, we're going to look at solving. So what we've got is, if we move the 3 cos to the other side, divide 3 by cos, that's the same as tan theta. And this is actually a problem we've just solved. So let's have a little look. So this one we have just solved, and this time we don't need to half it or double it or anything. So the two values we get coming out there were 1.25, if I remember correctly, and 4.39. And these are in radians as well. So there's my 4 solutions to that problem. Okay, question, would you say that? Yes, I would certainly say don't expand this, because then you get a cos theta sine theta and then a minus cos squared theta, and it gets very tricky. The fact it's given factorized for you is brilliant, because you've got everything kind of in the two factors that multiply to make 0, and you can solve it in two kind of separate branches. And one of them, as you notice, was an answer to a previous question. So it's deliberately set up that way. But a really good question. Okay, we'll move on. So a bit of mechanics now. A car is traveling at a speed of 13 meters per second along a straight road at time 0, and we're looking at the interval 0 to 6. It's following this type of acceleration. So what we should begin to recognize here is that this issue is a variable acceleration problem. So what we've got going on is we're asked to calculate the speed, and we've got to work back from the acceleration. Okay, so let's have a little look. First one. So we're given that the acceleration is equal to 0.8t. The reason we know that this is variable acceleration is because we're given acceleration as a function of time. So what we'll do is, in order to get from acceleration to velocity, we need to integrate that. And this comes from variable acceleration as a chapter in mechanics. It links to kind of rates of change and working backwards. So if we integrate the acceleration, v is equal to the integral of 0.8t with respect to t, which is going to be over 2 plus c. Okay, and so we add 1 to the power and divide by this. So what we end up with here is 0.4 p squared plus c is the velocity. And this whole plus c thing is important, because we know at the initial time it's already traveling at 13 meters per second. So what I can do is I can put that information in and say 13 is equal to 0.4, t would be 0 because it's the initial time, plus c. So 0 plus c is 13. This tells us c is equal to 13. So now an actual function of the velocity is going to be v equals 0.4 t squared plus 13. And there we go. And so when it says calculate the speed of the car when t equals 6, we literally just sub t in as 6. Ooh, not 3. T equals 6. And we get that the velocity should be coming out, or the speed should be equal to 27.4 meters per second. Okay. Right, so the next part II, here we go, is calculate the displacement of the car from A when t equals 6. Okay, so the displacement here is another load of integration from the velocity. So we're going to integrate that again. And what we're integrating is 0.4 t squared plus 13 with respect to t. Okay. And so integrating this carefully again, add 1 to the power and divide by it. So we're going to get 0.4 t cubed over 3 plus 13t plus another constant, which you could call c if you wanted, but maybe call it k as a different letter. And that'd be great. And so here, what we're looking to do is work out actually what k is. And since at time 0, the displacement is 0, because we're starting it from sort of a fixed point, then what we'll have is that k will go to 0 in this one. So now what we're kind of left with is this scenario for the displacement. And all we're looking to do is sub in what it wants, which is when t equals 6. So if we sub in t equals 6 to this, we end up coming out with s equals to 106.8 meters. And obviously as well, try to remember your units. That would be great. Cool. Okay, right, we'll move on. The next question, so this is kind of relating to the scenario we just had. We've got 3 graphs, and it says for the scenario we've just looked at, which of these is most appropriate to represent the motion of the car? And so it's not immediately obvious, but what we need to think about is the car was moving at the initial time. So here, what we've got going on is we're looking at a scenario where it's flat and the car isn't moving. So figure 1 doesn't really work. And likewise, this one isn't kind of constantly increasing. So this doesn't work. And as a result, the most appropriate would be figure 2. Right, let's have a little look. Let's see. So next question, for each of the other 2. Yes, so stating the reason is essentially, like we said here, for the first graph, 0 initial velocity. That doesn't match our scenario. And this one isn't kind of constantly increasing. So that doesn't work either. Right, cool. Let's move on slightly. So a statistics question now. And we've got a teacher thinks that 20% of the pupils in a school read the Dino comic regularly. Okay, so see what they've done there. And he chooses 20 pupils at random and finds 9 of them read the Dino. Test at the 5% significance level whether or not there is evidence the percentage is different. Okay, so this is a really key question. This is hypothesis test question. And actually the wording of the question is really important here, indicating on what we should do. Lots coming in the chat. I'm just going to try and keep up this as well. Right, so I'm going to fit in as much as I can now. I think we'll look through this statistics question, and then I'm going to talk a little bit about Snap Revise and other opportunities to go through other topics. So I'll carry on with this one for now. So here we go. This is, as we said, a hypothesis test question, but what's really important here is that this wording, that it's different, actually implies something really important, and it tells us that this is a two-tailed test. Okay. So obviously the order different schools go through and do the course, some people may not have met this yet, but if you have, hypothesis testing is really key part of the statistics side of the course. And it looks at whether we're judging whether there's evidence to reject or accept a hypothesis. And this one is looking at the binomial distribution. So what we've got here is we know it's a two-tailed test because it asks if it's different. If it specifically said is greater or is less than, that would be the wording that's suggesting it's a one-tailed test. So hopefully that's clear, but if that isn't something you've seen before, just bear in mind the language of these questions, for statistics particularly, is really important. So what we've got is we write out our hypotheses. So H0, the null hypothesis, is we kind of go with the default position. I'm sorry, not row, P equals 0.2. And H1, the thing we're testing is that the probability is not 0.2. Okay, yes, absolutely. So what we've got is we're looking at a binomial distribution where n is 20 and p is 0.2. And obviously with the technology we've got now, the calculators have the binomial cumulative function in them. And also there's, traditionally we would use tables in a book, but actually this is all set up in the calculator quite nicely. So using that function on your calculator, we can do this hypothesis test. What's really strange about the two-tailed test is there's always one that's wildly not going to work. So it's always going to be leaning towards one way. The thing we have to remember for a two-tailed test is to half the significance level. So each tail is 2.5%. Okay, so what we'll do is we'll have a look at this question now. And the kind of key test statistic we've got is for 9. So we try 9 out. So if we put this into our cumulative distribution for the binomial, n is 20, p is 0.2, and we can try x out as 9. And what we'll do is we'll find the two tails. So when p of x is greater than or equal to 9, so that kind of tail that we want to look at, that's essentially 1 minus the probability that x is anything less than or equal to 8. Okay, and what we have here is we end up with 1 minus 0.9900, whatever it ends up being, which is 0.01. Okay, this is within our 2.5%. So it's a rare enough case to be evidence that we need to reject the null hypothesis. So this allows us to actually say there is evidence that the null hypothesis was wrong, and therefore the readers of the Dino does differ from the 20% that was suggested. Okay, so this is the evidence that it's not 20%. For the next part of the question, which I'm just going to talk about because it's very similar and kind of ties in, is state all the possible numbers of pupils from a sample size of 20 that will make it significant at the 5% level. So here what we're looking at is the binomial scenario, again, very similar to what we've just done. And when we put this into our binomial distribution, we'll see that actually from any value from 9 up to 20, that percentage is within the critical region, so that works, or also 0. Okay, so this is something whereby we're using the tech, we're using like the calculators, ClassWiz, or any that have this information stored in them, or the tables in formula books, to look up the binomial cumulative up to the probability. Where most people go wrong with this is actually the 1 minus scenario and not choosing 8 when you want greater than or equal to 9. So it's really important that we kind of cut it off at the right point. Okay, but this was a particularly challenging question, particularly if you didn't have the calculator, it would be a real struggle. But hopefully that's kind of clarified the ideas around two-tailed and one-tailed tests, and we should look out for those scenarios in terms of the wording of statistics questions. Right. Right, let's have a little look. So what I'm going to do now is I'm just going to quickly show you kind of the other resources we've got on Snap Revise, and hopefully with this be able to share my screen but show you kind of some of the stuff we've got, as well as some giveaways and other bits. So let's just move on to that quickly. I'm just going to stop sharing this PowerPoint, and that should be back to me. And let's have a look if I can end that. Right, that's good. And so now what I'm going to do is I'm going to hopefully share the tab I've got open with Snap Revise. Let me just check that's all on there. Okay. Sorry guys, I don't want this to mess up. And then I'd like to show you some of the stuff on the website and make sure everything's nice and clear for you. So let's have a little look. Share. Where's it gone? Here we go. Do let me know if you can't see this at all. Okay, hopefully that's loaded. Might just be taking a second. Looks like we're there. Okay, so on Snap Revise, I'm just going to show you the main sort of stuff on the kind of page and what you'll have access to. So for the maths course, what we've got going on, there's loads on here, and the kind of first thing we'll look at is if you go through the different topics, you'll see for year 12 and 13, there's loads. There's all these different topics really broken down, and these kind of yellow button ones are ones that have kind of you started or you've done some work with, and it will change color accordingly. What is excellent with this is if you go on and you look at, say, for example, Introduction to Proofs, it will start with a really quick diagnostic quiz. And what we'll have is approximately 1 to 3 minutes, as it says. I'm going to go through this really quickly, just guessing, and see what happens. So work through the quiz, you answer what you can, and kind of, you know, give it your best shot so that it's useful. And so we'll just do this really quickly and see what happens. And so it should be just 10 sort of quick questions to get a general idea of what you understand about the topic. And then at the end of this, the kind of useful part we get to is it kind of gives you a breakdown of obviously how you did, but also the kind of bits you don't know, the bits you do know. And this now builds into tailoring your learning and the resources that are provided instantly for you to work on those skills. So what we can do now is get started, and we'll have some videos here that will begin, and they'll kind of be on all the different topics, but these kind of yellow parts here will allow you to jump to the bits within the video that you're struggling with. So it's really tailored to kind of being snappy, obviously, and hitting the points in the course that you're struggling with. So really handy. What you'll also have on here is a kind of comment section whereby you can message a tutor and ask any specific questions, and they'll get back to you and be able to follow up on. So there might be bits you still don't understand, and that'll be something you can follow up and clarify. So really handy. And so what we have as well is an exam pack. So all different questions. And the great thing about the resource on here is they're all brand new. They're all questions that have been written to the standard of A-level and to your exam board, but they're not going to be repeated from other places. And I know a lot of students hate the fact that they might have wasted resources that they wanted to use as a test. And these are just brand new questions made up and tailored to you. What we've also got is a revision guide. And these are some really nice notes, really clear, breaking down obviously some big topics. Proof is a particularly difficult one for a lot of people. And there's some excellent notes that you can download, print, and kind of use at any time to revise. So that's for every topic. So really good. And then, as I said, if we go back, we'll see now that within that scenario of different topics, it's become yellow because I've started it. and I can kind of track my progress within each topic. And that's for year 12 and 13. For, as you can see, so many different points of the course. What we've also got is we've got the web classes. So yeah, revision guides are on every single topic. They've been produced, a really lovely set of notes that is directly targeted at specific topics. The web classes, these are done twice a week. So I do 2 classes a week, one on a Monday, one on a Wednesday. And there's a schedule here, so you can see what's coming up and what I plan to cover. And that's great. So if you take part in Snap Revise, you join the packages, which I'll look at in a moment, you'll be able to access these web classes, ask questions, and have direct interaction as they go along, as well as obviously looking back at previous classes. So the ones that have already been completed, like these, you can go back and watch, make notes on, and again, follow up any other topics that you perhaps still struggle with. So this is kind of a real perk to have, and we have this for our other subjects as well. And then drop-in tutor, that is also on a Monday and a Wednesday. You can drop in to one of these live sessions with me and ask any specific questions that you have. So if you're really stuck on a particular topic, you can kind of essentially have the one-to-one tuition, ask the question, go through examples, and I'll give you kind of direct feedback and be able to explain basically anything on the course that you want really clearly broken down. So quite handy. And just kind of showing you some of the other features, I think the web classes and the drop-in tutor is essentially really handy because you're getting the one-to-one tuition, but the notes and the quizzes are all brilliant as well. Let's look at the plans, the different sort of setups we've got. So here are the different kind of price ranges. As I said, there will be a free giveaway today. So if you do want to take a picture and share it on your Instagram story, there will be a package given away for free. So that would be great. And as I said, the kind of key difference here, if I show you the comparison, is obviously you get more for each package, but the tutor chats support, so the kind of one-to-one service there, the drop-in and the web classes is the key thing that is part of the ultimate package. So essentially £50 is what, you know, an average cost for a tutor really is for A-level maths, but you're getting the web classes every week and the drop-ins. So you're getting loads of opportunities to have one-to-one tuition. So that's a really good package to kind of be aware of. And as I said as well, you've got the backlog of web classes that you can go to and follow up on. So that should be fine. And as I said, all brilliant resources. So you do get different bits for each package. The basic, you get the revision guides, you get the bite-sized videos, so you can sort of test yourself and revise from. But each kind of upgrade gives you a little bit more. So really the ultimate package gives you the tuition and is something you might want to consider. Excellent, right. And then finally, I think they're kind of the main things on there. Brilliant service and tailored to you, which I think is quite unique. Let's just go back and quickly finish off with the other kind of giveaways. Hopefully that's all clear and we can still see my screen. Let's have a little look. Do let me know if this isn't being shared anymore. Right. Okay, so I think I just need to share the final points with you with those discount codes, and then we'll be good to go. Some technical issues here, guys. Let's have a little look. Okay, so yeah, the final things to say, because I'm just struggling to get the PowerPoint back open, is we have got a £10 off code, which is capital M 10, as in 10, and that gives you £10 off for your first month, and that expires at midnight tonight. I'm going to just try and load that up so you can see it, and then we are going to probably end there. So let's have a little look. Back on the PowerPoint, here we go. And hopefully that's something we can all see now. Maybe not. Oh, there we go. Sorry, there's a bit of lag on here. There we go. So moving on, just to kind of wrap this up. Another kind of thing is the mock exams. Obviously, it's a really key time of year. There are live web classes happening all the time. So if it's that actually physics or biology or one of your other subjects is a priority at the moment, there are live web classes happening all the time. And this is something we do for free on YouTube. And there will be more and more of. So do look out for those, but it won't obviously give you as much of a tailored one-to-one experience as some of the other packages, but worth sharing and making yourself aware of for next time. And then finally, the last thing I said is this here, the capital M 10, that is a £10 off discount code for your first month. So that expires tonight. If you do want to use that, you are interested in it, go for it. And as I said, it will run out tonight. So that might be something you want to use. Excellent. Right, guys, hopefully that was useful, and good luck if you've got lots of mocks coming up. We're nearly there with this long term at school now. So hopefully we're kind of getting to the point where we can relax a little bit. I know it's a stressful time. Well done. And as I said, it might be something you want to follow up with to have the one-to-one support. But yeah, keep revising. Best of luck and have a good week. I think we're going to wrap up there. I'm not sure when the winner's going to be announced. I've just seen the messages here. I'm guessing over the next 24 hours, so that will be sorted. So if you do want to take a screenshot, still upload it to your Instagram story, make sure you tag Snap Revise in it. And then, as I said, there'll be a free account given away. So hopefully that'll be you. Good luck. Well done. Have a good week. And I think we're going to wrap up there. So I'll just stop sharing my screen again. And I think that should be back to me. I think we're pretty much ready to finish there. Cool. Well done, guys. Have a good week. And yeah, enjoy this final part of the term. Brilliant. Okay, let's end that there.